Okay, differential equation. What are they? Some of you have had this lesson before, but majority of you did not attend. So I'm going to go through these notes, which are on your bright space. Yeah, it's about differential equations. What are they? Well, we know what is an equation. An equation is a relationship between two variables. For example, x plus y is equal to 3. It's a formula that connects x with the y. Or you could have x squared minus 4 equal to 0. That is an equation. That is a quadratic equation. What is a differential equation? Differential equation will have a relationship between three things. Between a variable, between x, a variable, a dependent variable y, and also a dy by dx, a derivative of some kind, or d2y, a second derivative. Basically, if you have them three, a variable, dependent variable, and a derivative of y with respect to x, this is called a differential equation. Differential equations, what are they? Well, we know what is an equation. An equation is a relationship between two variables, a dependent, a variable x, a dependent variable y, and that is one type of equation. That's a linear equation. Or you can have a quadratic equation, x squared plus minus 4 equal to 0. That is a quadratic equation. Differential equation will have another term, such as a derivative of y with respect to x, a dy dx, or in some notation you can have a prime, a function of x prime, okay, or a double differentiation. Basically, if an equation has the derivative, then this is called a differential equation. I would like you to go to on the bright space and bring up the topic of differential equations. It will look something like this on your bright space, and basically I'm going through these notes and trying to explain it to you. One type, that is an example of a differential equation, dy by dx equal to 5x. So it's a relationship between a derivative and an x. And this is called a first order because the power of y, or the power of the derivative, is equal to 1. That is a first order. A second order would look like something like this. d2 dx squared plus 3 dy by dx plus 4y is equal to e to the power 2t. No, actually this is 2x. Okay, so that is a relationship between a derivative, a second order derivative, a first order derivative, a y, and an x. So this is called a second order differential equation because the highest power is 2. So solving differential equation. What do we mean by solving the differential equation? Well, we said the differential equation will contain a term like dy dx or d squared y by dx squared. And by solving the differential equation, we need to go back to the original function of y. Yeah, so going from dy dx to y, or going from d square y dx squared to y. The way we do that, we know we've done that in the integration. The first method we're going to consider is by direct integration, i.e. going from d dy dx, integrate this function to get something like y plus c. That is one example of the differential equation. This is the differential equation, and we can solve it by direct integration. And the way we do that, we integrate this function as we have done before in the integration. We go from here to there, and the way to do that is to increase the power of x by 1. So it's originally 1, increased by 1, it becomes 2, and you divide by the new power. And don't forget to put a plus c, the constant of integration. Constant of integration. You must put this. And what it means that this function has, this is called a general solution. General solution. Because it will have a family of solutions. That c could be anything. It could be 1, it could be 100, and it could be 1 million. And you will see the graphs plotted on one of the slides, which is this one, that one here. And this shows like you've got a family of curves, a family of solutions. If we have more information, we could have a specific solution, a particular solution. So if we have a value of x and a value of y, then we can find c, then you could have a particular solution. So in the example we have used, we got y as equal to x squared divided by 2 plus c. As I said, this is a general solution. So if we want to find a more specific or a particular solution, we need to find a value we need to be given a value of x and a value of y. In this case, if x equal to 2 and y equal to 3, we can actually be more specific about the solution. So you're gonna have like something like this. The curve will look like that. And the way we can draw this is because we are given the value of x and the value of y. We can plug these values into this equation. So y is equal to 3 and x equal to 2, so that's 2 squared divided by 2. We can find c. In this case, c is equal to 1, and this will give the particular solution. And in this case, it's going to be y equal to x squared divided by 2 plus 1. So to summarize, we've got two types of solution: general solution and a particular solution. The general solution, if we have a constant of integration, so you're going to have a family of solutions. The particular solution is when you don't have a constant of integration. So you actually have a known value. So this is, we got a general solution and a particular solution. So let me just remind you that a differential equation will contain something like this, a derivative. And by derivative, we mean a dynamic relationship. For example, rate of change of velocity with respect to time. That will give us acceleration. You'll find that a lot in dynamics or mechanics. Rate of change of s with respect to t. Displacement with respect to t. That will give you velocity. And you will see terms like decay, like radioactive decay. That is some variable changes with time. Rate of change of anything, of temperature with time. Temperature with time. Okay? Because some people get confused sometimes when they are asked the decay is so and so, they cannot translate it. Decay means the rate of change of something, of some constant with another constant, with another variable. Let's have another example. This is an example of a differential equation. The way to solve that, we're going to solve it by direct integration. We've got all the y's on one side, all the x on one side. So the way we do that, we integrate this function to get y. To get y is equal to integration of this function, 3x squared minus 6x plus 5 with respect to x. And that is equal to 3x squared becomes x cubed divided by the new power 3 minus 6x divided by 2, and the 5 becomes 5x, and don't forget the constant of integration. This will reduce to x cubed minus 3x squared plus 5x plus c. So this is the general solution. And we have used direct integration to get this solution. Let's do another example. Solve this equation. Solve x dy dx equal to 5x cubed plus 4. The first thing we need to do is to get all the x's on one side. So in this example, we need to divide through by x. Divide each term by x. So if we divide by x, you're going to have dy by dx equal to 5x cubed divided by x becomes 5x squared plus 4 divided by x. So we rearranged the equation so that we can integrate it using direct integration. Okay, so this will become y is equal to integration of this new function, 5x squared plus 4 over x. This will equal to 5x cubed divided by 3 plus, well, this is 4 times 1 over x. Okay, that is 4 1 over x. So the integration of 1 over x is log, the natural log, ln of x. Okay, so this give us 4 ln x plus the constant of integration. And that is the solution. This is the solution. That is the general solution. Let's have another example. That's another example. And it says find the particular solution of the equation. That's the equation. And we have a value of y and a value of x. When x equal to 0, y is equal to 3. Okay, and once again, get the x's to one side. So you get dy dx. My pen is running out. Dy dx equal to 4 divided by e to the power x. I'm just dividing through by e to the power x. Just rearranging my equation. To find y, we integrate. So that's y is equal to that becomes here 4e to the minus x. So y is equal to 4e. If you look up your table of formula for the integration of e to the power x, that is e to the power x minus x times minus 1. This comes from here. So y is equal to minus 4 e to the minus x, minus 4 e to the minus x plus the constant of integration. Now we are given a condition x equal to 0 and y is equal to 3. We substitute that in the value. You got this equation here. That is a general solution. So we're putting the value of y in this case equal to 3 equal to minus 4 e to the minus x, which is 0, e to the 0 plus c, and that's equal to 3 minus 4. Anything raised to the power of 0 is 1, so that becomes 1 plus c. C is equal to 3 plus 4, 3 plus 4, C is equal to 7. So the general solution is y is equal to minus 4 e to the minus x plus 7, and that is your answer. So this is one method of solving the differential equation, and this is solving differential equation by direct integration. What I like you to do now is to go on exercise 1. You should be able to solve all of them, and this is the exercise sheet, differential equation by direct integration. You've got a few questions there. You've got the answers. I'd like you to have a go at all of them. You should be able to do all of them. Some of the solutions are not right. This is not right. By the way, this is the differential equation by direct integration. This exercise is actually on this bright space, and we can discuss this further on the chat time. For Tuesday lesson, it will be around 1 o'clock. I'll post that on the bright space. If you have any questions, let me know. The next video will be on the other method of solving the differential equation, which is by separating the variables. I hope this is exciting for you. I know it's a little bit difficult. This is a new method of teaching, but at least you don't have to see my face. Okay, see you later. Enjoy yourself.